Welcome to this explainer. Let's just jump right in. I want you to start by picturing a really quiet forest. The trees are tall, the air is perfectly cool and still. Now imagine a young man sitting entirely alone under an apple tree. He's not running some complicated experiment in a lab, and he isn't even writing in a journal. He's just thinking. But in that one quiet moment, something is about to happen that will completely change how the entire world understands the universe. Today, we're diving into the extraordinary life of Isaac Newton, a guy who essentially spent his entire life just listening to the universe until the universe finally answered back.
I mean, it sounds like something a little kid would ask, right? Why did the apple fall down? But that simple little question actually frames the core mystery of our entire story today. Newton looked at a falling apple and asked a question that literally no one had thought to ask in quite that way before. And it just goes to show how quiet observation, patience, and some serious persistent curiosity can unlock the deepest secrets of nature.
All right, let's get into section 1, a quiet, curious boy.
So to really get Newton, we have to start with his early years, which were honestly incredibly fragile. The year was 1642, in this tiny village called Woolsthorpe. His start in life was anything but easy. He was born so tiny and weak that his mother actually said he could fit inside a large cup. People genuinely weren't sure he'd even survive. His father had died before he was born, and when Isaac was just 3 years old, his mother left to remarry. So he was left behind with his grandmother and grew up as a deeply lonely kid. He wasn't the type to be out playing loudly with big groups of friends. Instead, he coped by quietly observing the world around him. He built little windmill models, made paper kites, and just studied how shadows fell. He was always watching. By the time he reached young adulthood and arrived at Cambridge University, he was this quiet, serious student who was finally stepping into a world of math and astronomy that felt custom-made for him.
Moving right along to section 2, the plague and the prism.
Now here's where things get really fascinating. Just as he was finally finding his place at Cambridge, absorbing all these massive ideas from greats like Galileo and Descartes, the world outside started falling apart. The Great Plague began sweeping across England, and Cambridge University was forced to shut its doors. Everyone was sent home. For most students, this was a massive setback, right? Just a total roadblock for their education. But for Newton, from 1665 to 1667, he entered these 2 years of deep solitude back in the quiet countryside of Woolsthorpe. And rather than pausing his learning, this intense isolation actually became the absolute crucible for his genius. Far away from professors and everyday distractions, he was able to think more deeply than ever before.
Working in absolute stillness, he decided to turn his attention to light. And using just a super simple glass prism, he made a completely shocking discovery. He actually proved that white light isn't just one single color, like everyone at the time assumed it was. When he passed the light through that prism, it spread apart, revealing that white light is really made of this incredible hidden spectrum of colors: vibrant red, orange, yellow, green, blue, and violet. That absolutely stunned the scientific world.
But his quiet curiosity didn't stop with light. He realized that the math of his day just wasn't advanced enough to describe the changing, moving universe he was observing. So what does he do? Well, he just invents an entirely new mathematical tool. He called it the method of fluxions. Today, we all know it as calculus. So yeah, sitting all alone in the countryside, he essentially created the exact mathematical language we needed to calculate movement and change. Absolutely wild.
Which brings us to section 3, the apple and gravity.
This brings us right back to that quiet afternoon in his Woolsthorpe garden. It is undeniably the most famous story in the entire history of science. The apple falls. Now, most people had seen apples fall a million times and never thought twice about it. But Newton asked a totally different set of questions. He thought, why not up? Why not sideways? Why does it always fall straight toward the earth? He realized the answer wasn't simple at all. There had to be this invisible, powerful force pulling the apple down. And then came the massive, earth-shattering breakthrough. He realized that if this force was pulling the apple toward the earth, well, maybe that exact same force was pulling the moon and holding the planets in their places. Gravity. Just one beautiful, enormous idea that connected a piece of fruit falling from a tree to the literal stars in the sky.
When the plague finally ended, Newton went back to Cambridge, but he was a completely changed man. He came back just bursting with revolutionary ideas. Because of the sheer depth of all that thinking he did during his isolation, he actually became a professor at Cambridge at the incredibly young age of 26. And as a professor, he didn't just sit around theorizing, he was building things. He built the very first reflecting telescope, using mirrors instead of glass lenses, which totally amazed astronomers all across Europe. His reputation was just exploding at this point.
All right, let's look at section 4, the laws of motion.
Now, you might think he immediately shouted all these incredible discoveries from the rooftops. But actually, no. Newton was a highly cautious guy. He liked to think slowly and carefully. He waited years, just calculating privately in his notebooks, refining every single detail, before he was ready to share his grand theory with the world. Finally, after years of quiet preparation, in 1687, he published the Principia. It was written in Latin, filled with intensely complex mathematics, but it did something that seemed impossible. It transformed the universe from this terrifying, unpredictable mystery into a beautiful, highly ordered mathematical system.
He brilliantly broke down the physical world into 3 surprisingly simple laws of motion. First step, an object stays still or moves in a straight line unless it gets pushed or pulled. Second step, force, mass, and movement are intrinsically connected to one another. And the third step, every action has an equal and opposite reaction. These 3 rules, working alongside his whole theory of gravity, suddenly explained almost everything that moves. The ocean tides, the orbit of the moon, the path of a thrown stone. He literally found the hidden rules that the universe follows every single day.
Let's move to Section 5, the complicated genius.
It is so easy to look at his work and just see this flawless god of science. But to truly understand Newton, we have to remember he was very human. He was a complicated, highly private, and sometimes incredibly stubborn guy. He wasn't always easy to get along with, and he had very few close friends. We really see his defensive side in his famous dispute with another brilliant mathematical mind, Gottfried Wilhelm Leibniz. You see, both men had independently developed calculus, but rather than celebrating this amazing shared genius, they got into this long, painful, and super bitter argument over who had actually invented it first. It was a messy dispute that ended up causing a ton of unhappiness for both of them. He honestly lived a life of striking duality. On one hand, you have these massive public achievements, calculus, gravity, the laws of motion, but on the other hand, he had these intense private obsessions. Secretly, Newton spent huge amounts of his life studying alchemy, literally trying to figure out how to turn base metals into gold. He also spent countless hours diving deep into theology and religion. You don't usually see this stuff in basic history books, but it really shows us a man who is genuinely searching for the hidden, intelligent design behind absolutely everything. He wanted to understand the intelligence of the universe, one question at a time. And that brings us to Section 6, Standing on Giant Shoulders.
In the final chapter of his life, he really steps out of the shadows. In his later years, Newton left the quiet life of Cambridge and moved to London, completely transforming from a solitary, secretive thinker into a major public figure. He poured his obsessive energy into a new role as Master of the Royal Mint, where he fiercely fought against counterfeit money. His contributions there were so immense that he was actually knighted by Queen Anne in 1705, officially becoming Sir Isaac Newton. After a life devoted entirely to his work, he never married and had no kids. He died peacefully in his sleep in 1727 at the age of 84. The nation mourned him deeply, and he was given the immense honor of being buried in Westminster Abbey.
But even as this towering public figure, he remained a really thoughtful guy. For a massive 24 years, he served as the president of the highly respected Royal Society. Yet despite holding one of the absolute highest scientific offices in the world, at his core, he was still just that same quiet man who wanted nothing more than to read, write, and think.
And honestly, nothing captures his humility better than this. In a very famous letter, Newton wrote, "If I have seen further, it is by standing on the shoulders of giants." Despite his unbelievable world-changing intellect, he knew his massive breakthroughs were only possible because he built upon the earlier work of thinkers who came before him, giants like Galileo, Kepler, and Descartes. He didn't see himself as the ultimate beginning of knowledge, but just as a traveler on a much longer continuing journey.
Which leaves us with this final thought for our explainer today. Every journey of discovery begins with one simple, quiet, and courageous act: the decision to simply pay attention, to look at the world around you and ask why. So as you continue your own learning journey, I want you to ask yourself, what will you choose to pay attention to? Because if you just stop, be patient, and truly look, what hidden laws of the universe might be waiting for you to discover them? Thanks so much for diving into this with me. Keep wondering, keep learning, and I'll catch you in the next explainer.